Imagine a world powered by the tiniest bits in the universe. Picture a city where the air is clean, the skies are clear, and energy is abundant. This is not a distant dream, but a potential reality, thanks to the groundbreaking advancements in quantum technology. A world without pollution or energy shortages. Envision urban landscapes where towering skyscrapers are powered by invisible forces, and every home, vehicle and device runs on clean, sustainable energy. This is the dream of quantum engines, a brand new technology just getting started. In cutting-edge laboratories around the globe, scientists are harnessing the peculiar properties of quantum mechanics to revolutionize how we generate and consume energy. These engines use the strange rules of quantum mechanics to make energy in a whole new way. Quantum mechanics, the science of the very small, reveals a world where particles can exist in multiple states simultaneously and interact in ways that defy classical physics. Quantum engines work differently than regular engines. Traditional engines rely on combustion or chemical reactions to produce energy, often resulting in pollution and inefficiency. They don't use burning or chemical reactions. Instead, quantum engines exploit the unique behaviors of quantum particles, such as superposition and entanglement, to generate power without harmful emissions. Instead, they tap into the energy of quantum systems, where tiny particles can be in many places at once. This phenomenon, known as superposition, allows quantum engines to access energy states that are impossible for traditional engines. This quantum weirdness opens up exciting new ways to make energy. By leveraging the principles of quantum mechanics, we can create engines that are not only more efficient, but also environmentally friendly, paving the way for a sustainable future. Imagine a future where our cities are powered by these incredible engines, where energy is clean, limitless, and accessible to all. The potential of quantum engines is vast, and as research continues, we move closer to making this vision a reality. The journey of quantum engines is just beginning, but the promise they hold is immense. With continued innovation and exploration, we stand on the brink of an energy revolution that could transform our world for the better. To understand quantum engines, we need to explore the fascinating and often perplexing realm of quantum mechanics. Quantum mechanics is a branch of physics that delves into the behavior of matter and energy at the smallest scales, such as atoms and subatomic particles. Unlike classical physics, which deals with the macroscopic world we see around us, quantum mechanics reveals a universe that operates on principles that can seem counterintuitive and bizarre. In the quantum world, energy and other properties are not smooth and continuous. Instead, they come in discrete units or packets known as quanta. This means that at the quantum level, things like energy, momentum, and even position are quantized, existing in specific, indivisible amounts. One of the most intriguing and perplexing phenomena in quantum mechanics is superposition. To illustrate this, imagine a coin spinning in the air. While it's spinning, it doesn't settle on heads or tails. It's in a state of both heads and tails simultaneously. It's only when the coin lands that it chooses one state. Similarly, a quantum particle can exist in multiple states at once until it is observed or measured. This concept of superposition means that a quantum particle, such as an electron, can be in a combination of states, like being in different places or having different energies, all at the same time. It's only when we measure the particle that it collapses into one of these possible states. This behavior is fundamentally different from anything we experience in our everyday lives. This strange and counterintuitive behavior is not just a theoretical curiosity, it is the cornerstone of how quantum engines operate. Quantum engines leverage these unique properties of quantum mechanics, such as superposition and entanglement, to perform tasks that would be impossible for classical engines. By harnessing the power of quantum states, these engines can achieve efficiencies and capabilities far beyond what we can achieve with traditional technology. Another important idea is quantum entanglement, which Einstein called spooky action at a distance. When two particles are entangled, they're linked, no matter how far apart. If you measure one, you instantly know about the other, even if they're light years away. This connection, which breaks the rules of normal physics, is vital for quantum engines. By messing with entangled particles, scientists can get energy from the quantum vacuum, an invisible sea of energy all around us. Regular engines use expanding hot gas to generate power. This is a principle that has driven the Industrial Revolution and continues to power many of our machines today. The internal combustion engine, for example, relies on the rapid expansion of gases to move pistons and generate motion. This method, while effective, is not the only way to harness energy. Another common method involves the flow of electrons through circuits, which is the basis for electrical engines. These engines convert electrical energy into mechanical energy, powering everything from household appliances to electric vehicles. However, both these methods have their limitations and inefficiencies. Quantum engines are different. They operate on principles that are fundamentally distinct from classical engines. Instead of relying on macroscopic phenomena like expanding gases or flowing electrons, quantum engines utilize the energy difference between quantum states. Imagine a staircase where each step represents a different energy level. Particles can move between these steps, and in doing so, they release or absorb energy. Quantum engines move particles down these stairs, releasing energy with each step. This process is highly efficient because it takes advantage of the discrete nature of quantum states. Each transition between steps is a precise and controlled release of energy, minimizing waste and maximizing output. This process is driven by the laws of thermodynamics, but in the quantum world, these laws manifest in unique ways. The second law of thermodynamics, which states that entropy always increases, still applies, but the mechanisms are different. In the quantum realm, particles can exist in superpositions and entangled states, leading to new ways of managing energy and entropy. By carefully controlling how particles interact, these engines can extract energy from the surrounding heat, even when it's cold. This is because quantum engines can exploit the tiny fluctuations in energy that occur even at low temperatures. This ability to harness ambient heat opens up new possibilities for energy generation, making quantum engines a promising technology for the future. The workers inside a quantum engine are particles called bosons and fermions. Bosons, like photons, light particles, like to clump together. Fermions, like electrons, don't want to be in the same state. Quantum engines use these special properties. For example, a Bose-Einstein condensate, where bosons are all in the lowest energy state, can be used to release energy in a controlled way. Quantum engines could be super efficient. They might get close to the Carnot limit, the highest efficiency possible. But building them is hard. Keeping quantum systems stable is tricky. Anything can disturb them, causing energy loss. Overcoming these problems is key to making real quantum engines. Quantum engines are still new, but they have huge potential. They could change how we make energy, powering everything from cars to phones. They could even power spaceships using the energy of the quantum vacuum. Because they can work at very low temperatures, they're great for cryogenics and quantum computers. Quantum engines are a big step in understanding and controlling the quantum world. This technology could change how we use energy, giving us a clean and sustainable option. Beyond energy, quantum engine ideas could change other fields too. Quantum sensors, communication devices, and even new types of computers could come from this exciting area. Our journey into the quantum world is just starting. Quantum engines, though young, show us a future where the impossible becomes possible. As we learn more about the quantum world, we open up amazing new possibilities. Exploring the quantum world will lead to incredible discoveries that will shape the future of humanity.